Hello everyone, I am Naneshwar Rajnur. Today I am going to discuss about RSA algorithm. RSA algorithm based on asymmetric key cryptography or public key cryptography. Till date we have covered three assignments. Now this is the fourth assignment that is based on cyber security. The RSA, the name derived from these three different scientists, that is Reeves, Samir and Adelman. They work in MIT and they derived this interesting algorithm in 1977. This algorithm used by modern computer to encrypt and decrypt messages. It is asymmetric key cryptography algorithm. Asymmetric key cryptographic algorithm means we are using two different key. That is public key and private key. Public key for encryption procedure and private key for decryption procedure. This is also called as public key cryptography because one of the key can be given to anyone. Means public key should be shareable. RSA makes the public and private key by multiplying two large prime number, that is P and Q. It is easy to find and multiply large prime numbers, that is n equal to P into Q, but it is very difficult to factor the number n to find P and Q. And this is the beauty of RSA algorithm. Finding the private key from public key would require a factoring operation. The real challenge is selection and generation of key. This is the main challenge inside the RSA algorithm. Which is that challenge? Selection and generation of key. So as compared to DES algorithm, RSA algorithm is more complex and more slower, but it is more secure as compared to DES algorithm. Now discuss about the RSA algorithm. First step, we have to randomly choose the two large prime number, that is P and Q. Now multiply these two large prime number P and Q and result will stored inside the capital N or N. Now for calculating the value of E or selecting the value of E, we have to first calculate the value of totient function. Then totient function, it is mainly denoted as phi. So phi equal to P minus 1 into Q minus 1. So what is the value of P? That is, it is a large prime number, that is P minus 1 into Q minus 1. Then we can choose the value of E such that it is not the factor of P minus 1 into Q minus 1. No? It is not the factor of totient function. Then we are having the value of E, so we can easily find out the value of D such that D into E mod of P minus 1 into Q minus 1. What is P minus 1 and Q minus 1? It is the totient function. So we can select the value of D such that the LHS part of this equation will be 1, means 1 equal to 1. Okay. Then we are having the value of encryption key, we are having the value of decryption key, then we can easily encrypt and decrypt our plain text. So ciphertext equal to plain text raised to E mod of n. What is plain text? It is the user message or it is the sender message. So plain text raised to E. What is E? Is the public key mod of n. What is the n? N is the product of P and Q. Then while encrypting this message is sent by the sender to the receiver. While the receiver will receive this ciphertext, he can use this formula, that is Pt equal to Ct raised to D mod of n. What is P? What is Pt? Pt, that is plain text. Plain text equal to ciphertext raised to D mod of n. Means the message encrypted by the sender, again it will be decrypted and you will get the original message. So you can see this algorithm using one example, that is first P equal to 3 and Q equal to 11. Basically in the algorithm they demand that to select the large prime number, but for calculation purposes I have taken the small numbers P equal to 3 and Q equal to 11. So n equal to 3 into 11 means n equal to P into Q, that is 33. This value required for the calculation, that is ciphertext and for plain text calculation. Then phi. What is the required or what is the need of phi? The phi value required to generate the value of V, so that phi equal to 3 minus 1 into 11 minus 1. What is 3 minus 1? That is 3. 3 means P. P minus 1, Q minus 1 equal to, that is 2 into 20. That is 3 minus 1, 2. 11 minus 1, that is 10, that is 20. So we have to factor this 20. Okay, the factors of 20 are 2 and 5. Okay, so we have to select the value of e such that it is not the factor of 2 and 5. Means we have to select the value different from this 2 and 5. Right? That's why we have selected the value of e equal to 7. We can also select as 11, 30, likewise. Now we are having the value of e. Now put this value into this equation. D into 7. What is 7? 7 is the encryption key or value of e. D into e mod of 20 equal to 1. Then we can consider or we can select the value of d such that LHS equal to RHS. What is RHS? RHS equal to 1. If we can put this value, that is 3, in this equation, then the LHS become 1. Okay, means it should satisfy that conditions. Then we are having the value of e, we are having the value of d. So we can encrypt our message and we can also decrypt our message. So ciphertext equal to plaintext raised to plaintext raised to e mod of 33. Means that is the plaintext that is 31. It is user message raised to e, that is encryption key 7 mod of 33, that is capital N, equal to 4. This is encrypted message. This is the original message 31. Original message 31, encrypted message 4. Now this 4 is sent through the public network, that is internet. While the receiver will receive this value, he will again regenerate the original message by this equation, that is plaintext equal to ciphertext raised to d. What is ciphertext or encrypted message? That is 4 raised to 3 mod of 33. What is 33? That is capital N equal to 31. Means using this public key and private key we can encrypt and decrypt our messages. So this is the simple discussion about RSA algorithm. I have uploaded the program in Python regarding RSA algorithm. You can follow these steps and perform the practical that is based on RSA algorithm. Thank you very much.